Our problem today is a prototype of a scissors mechanism. I originally had printed this on my resin printer, but I found it just wasn't rigid or precise enough, so I ended up CNCing the links out of 14 gauge brass instead. Next up was to make a fixture block so I could keep the links square and keep them from rotating during reaming. The upper links will get clearance holes, while the lowers will be interference fits. Then it was over to the lathe to make a mandrel for the pins. A taper on the end should allow me to see what I'm doing and install the pins more easily. Then a 100 thou deep hole in the tip, so I still have about half the pins sticking out. Now the obvious choice would be to use pins with a length equal to 2 times the thickness of my brass. But I realized that the chamfers on the end of the pins would severely compromise my interference fit. So instead, I'm using longer pins and pushing them all the way through while hoping I can come up with a way to trim them flush on one side. Here you see the pins installed, sticking out both sides of the links. Now these pins are hardened, so the idea of machining them is daunting at best. Not to mention that the machining stress will likely be greater than the strength of my press fit. So I've decided I'm going to try to grind them. I've installed a 3x speeder on the Bridgeport. This should get my Dremel cutoff disc spinning at about 10,000 RPM. Now the video is sped up 8x here, but despite the slow going, I think grinding was still the right call. 17 pins and 3 grinding discs later, the links are ready for assembly. You'll notice a taller pin on the 3rd lower link. This is the drive pin. And if my math is right, the driven pin on the end should see 2.33 times the travel of the drive pin. It looks like this should fit the bill. Plenty rigid and no perceivable slop. A lot of tinkering to get here, but I'm really happy with how it turned out. Thanks for joining me in the shop today. I hope to see you next time.